My name is Marco Santello. I'm the director of the School of Biological and Health Systems Engineering and the director of the Neural Control of Movement Laboratory at Arizona State University.
I'm David Fleischer. I'm a member of the Division of Gastroenterology at Mayo Clinic in Arizona and a professor of medicine in the school in the College of Medicine. Marco and I have been able to collaborate with some other members of the teams on each side on a project that actually looked at the ergonomics of endoscopy. The actual title of the paper that was published in Gastrointestinal Endoscopy is called Characterization of Right Wrist Posture During Simulated Colonoscopy, an Application of Kinematic Analysis to the Study of Endoscopic Maneuvers. It's really a takeoff in a wonderful example of collaboration between clinical medicine and science. Don't you agree, Marco?
Absolutely.
So one of the things that anybody who works in endoscopy knows is that musculoskeletal injuries occur frequently. Different surveys talk about it occurring 40 to 80% of endoscopists develop musculoskeletal injuries, and it's important. It's almost considered an occupational hazard of doing that type of work. It's important enough that the ASG, the American Society for Gastrointestinal Endoscopy, has put position papers on this, and one in 2010 pointed out the importance of musculoskeletal injuries and attempts to reduce that. As a physician, I've been struck by most of the medical literature is descriptive. There's surveys that says X number of people get this and a certain percentage do, and it says what the injuries are. But the science behind it has not been as forthcoming. That's why it was particularly exciting that our group at Mayo Clinic, Arizona was able to collaborate with Dr. Santello's group on an ASU seed grant, ASU Mayo seed grant, that allowed us to actually study in more detail how the injuries may occur. So Marco, tell us a little bit about it, because you're the guy who's the brains behind it.
No, absolutely. So our relationship started really at one of the ASU Mayo workshops after we were reporting on the progress on some of the ASU Mayo funded project. And I've been working with the Mayo Clinic on a project in particular looking at the effect of carpal tunnel syndrome on hand function. And this is where you basically asked me the question, do you think that this work could also be applied to the problem of overuse injuries in endoscopy? And this is where our collaboration started. So, I came to the clinic, I looked at some of the procedures, and this is how this project kind of took off. And the contribution that we thought we could have provided to this problem was actually quantifying the movement patterns that endoscopists generate during these maneuvers. And in particular, trying to link the movement patterns with the likelihood of causing these particular injuries, which are fairly serious. As you taught us, these overuse injuries can actually be fairly debilitating for the for the endoscopists, right?
And when we started to actually look into it, we talked about different ways to set it up. One way was to actually study the procedures when they began. We then came up with the idea with using simulators because they've been used both in training of endoscopy, and we thought it'd be useful to utilize this for the study so you could get reproducible methodology. And we've worked with Symbionics out of Mentor, Ohio, and they provided the simulators for the study. They're one of the simulator companies that many people use. And so we could actually say, if we're going to study something, we could use a simulator so it'd be reproducible. And then the technology, I was really not aware of the different sensors that existed, and that's what I learned from you about the different sensors. So.
Yeah, basically what we do in the lab is motion tracking, and we also look at force recordings and all these kind of procedures to get a better understanding of how the brain controls upper limb movements. And in this particular application on endoscopy maneuvers, the question was whether we could characterize specific movement patterns that might be linked to overuse injuries. And our take on this was to basically characterize the extent to which endoscopy leads individuals who do these procedures towards the extremes of range of motion, which are normally associated with injuries and with strain of different kinds. And this is what we did. So we came up with our own metric of characterizing how often during a typical endoscopy procedure, in the simulator, we could characterize this kind of risky areas during the procedures, and then start to put some kind of objective, quantifiable metrics to say, this is how often you spend during a normal procedure in a range of motion that you probably shouldn't be in.
Yeah, and I recall I had read about the different sensors and the different equipment that's used for that, but I first saw it in your lab, and maybe you can describe for the people what
absolutely. So for the paper that we just published, we used a fairly simple approach, which basically consisted of a magnetic tracker that can measure position and rotation in 3 dimensions.
And that's just a glove that when we were using, the endoscopists were using, they put on a glove and it had
Correct.
measurements in it. Yeah.
Correct. So the endoscopists basically wore a glove, and we had a sensor on the back of the hand and a sensor on the elbow, which basically provides the inertial frame of reference. And based on this approach, we could measure 3 degrees of freedom of the wrist motion. And we wanted to focus on the wrist based on the cervix, which is one of the joints that gets most affected by overuse injuries. And based on this first study, what we found is that we could characterize differences in the extent to which each degree of freedom, for example, flexion extension, adduction abduction, and pronation supination, we could characterize how often in these particular degrees of freedom are distributed throughout an entire procedure. And within each degree of freedom, also characterize how often you are at the extreme ranges, at the extreme regions of the range of motion of that particular joint.
Yeah, so I guess in some extent, when endoscopists are doing the procedure, there's so much going on that you sort of become second nature and you really don't calculate. And I don't even say to myself, this is normal, this is an extreme range of motion. So how are those actually defined when something's in the extreme range of motion? What does that mean?
So basically what we do at the beginning, we do a calibration procedure whereby we ask which are subject dependent. So each subject has different ranges of motion. So for each subject, what we measure is the extreme range of motion. For example, with the sensors on the wrist, we would ask them to assume an extreme supination or pronation. And then based on that, what you do is basically characterize the midpoint of the range of motion. And then we then define for that particular subject how often you encounter those particular areas. And the same for flexion extension and the same for adduction abduction.
Yeah, and in this study, we just took docs who have a broad range of experience. This was 12 of the faculty at Mayo, and we put them through the simulator as reported in the paper. The methodology was they used the symbiotic simulator. They did colonoscopic procedures after getting used to the equipment, and then they were chosen. 2 of the different cases were done. So we had reference points on the 12 individuals and what they did. And I guess if you had to summarize the findings, Marco, what would you say we learned from that?
What we found is that there is definitely a tendency, even for experienced endoscopists, to spend a significant portion of the time during the endoscopy procedures in a region of the range of motion that we consider to be at risk for developing musculoskeletal injuries. And this is significant because it indicates that even though we had a small sample of subjects, even those who have 10 plus years of experience might still preserve this tendency for doing a motion pattern that we think they shouldn't be engaged in. And this speaks also, it's very informative with regard to what kind of training we should give to novices. And this goes back to this idea of using a simulator in the lab where we can now characterize what is the optimal way of training endoscopists in a way that do not accumulate these kind of bad habits of straining their joints over hours and hours and hours by the time they're going to do this in a clinical setting.
So I guess if you'd summarize the results of our first study, we focused on this wrist motion during colonoscopy, and of course you could focus on other joints, and we'll talk about that in a second. But this was wrist motion during colonoscopy, and again, people that had anywhere from a few years experience to 20 or 30 years experience still had as much as 30% of the time in the extreme range of motion. So it said, at least to me, my takeaway from it was even folks who've been doing this for a while tend to do this, and there ought to be a better way to do this. Maybe it's the training, maybe it's the equipment, but one of the things then we started to look at was looking in, instead of taking more experience endoscopy, we put together a second project that takes first-year fellows before they, so to speak, develop these patterns, and we've started to look at those.
Yeah, and so now we're in the process of analyzing that data to see a potential link of whether these patterns persist or they're kind of removed as they, as they become more accustomed with the procedures. And the preliminary analysis actually shows that regardless of how often you practice, you see that these patterns persist. So they don't actually go away with more training, which is interesting in a way because it says that maybe we need to come up with better ways of training the endoscopists. But it also shows that if we don't intervene and give some kind of feedback or change their way in which they operate, they might have these habits so ingrained they're going to take them with themselves, in their clinical practice.
Yeah, that's what I took away from it. So here you have these endoscopists who've never really done endoscopy before. We study them at baseline before when they just use a simulator, and then 3 or 4 times every 3 months or so to see the patterns. And then that was a second study, and I say if you look forward to what the things we can do next, other joints, other equipment. So what's your vision, Marco, of where we ought to go from here and where we are going to go from here?
Absolutely. So this first study was very promising, and it provided some significant insights into the next big questions. And so given that endoscopy involves bimanual coordination, it involves both limbs that do very different things, because they have very different tools. It's, from a scientific perspective, it's a very interesting problem. Because now the cognitive burden on coordinating 2 limbs and making sure you don't strain your joints is even higher than just looking at one joint. And so what we're doing now, we're setting up our motion tracking lab at ASU, where now we're going to have cameras tracking the motion of both limbs together. And we're not just focusing on the wrist anymore, but beyond the wrist, meaning we're also going to do elbow and the shoulder. So we're going to have a total of 6 joints. And we could also look at at the back, at the spine, making sure that as you do this particular movement patterns, also you don't put strain on the upper back or lower back, as we know from the surveys is also another problem with endoscopies.
Well, I'm excited about this, number one, because when you read the literature, the surveys give you some background information, but be able to try to understand it, and that allows us to likely change the patterns of the activity and hopefully reduce this, because as I say, I've been doing this for a while, and all my friends have some musculoskeletal injuries that I've had. It's what you can expect. So I think you'd predict that there's hope for both understanding and doing something differently.
Absolutely. I think, like in any other movement patterns, if you don't have a very good model, to follow, or the correct model. In this particular case, it's not about, the issue is not about how accurate you do the procedures, because these are highly skilled, highly trained individuals. The problem that we identified is that emphasis has been put on the safety of the patient, and it should be, but the safety of the endoscopist has kind of been put aside. So now we want to look back at this problem, starting from understanding what kind of movement patterns people have. From there, look at ways in which we could correct them and make sure that, maybe even create standards for training so that we could hopefully, reduce or minimize as much as possible the incidence of musculoskeletal injuries in this particular category.
Right. So it's been a good start, and I look forward to further working. Dr. Santello. Good. Thank you.
Thank you.